Good morning, class. So this is our frame. This is on stiffness matrix method for 2D rigid jointed structures. Or this is commonly known as two-dimensional frame. Ito ay nagre-resist ng moments as well as axial forces. So ito ang ating sample, this figure. The support at node 1 is pin connected. At nodes 3 and 6, this is fixed support. And then we have the coordinates. At node 1, that is 0, 0. And then node 2, the coordinates is 0, 6. 6 meters ang height. And then at node 3, that is 4, 0. Then node 4, you have 4, 3. Then node 5, you have 4, 6. And then at node 6, you have 8, 0. Node 7, you have 8, 3. Tapos, yung displacements naman, or yung freedom, you have here U, V, tsaka yung theta. Remember na yung U displacement, that is the horizontal or X displacement, and then V, that is the vertical or Y displacement, and then theta is the rotation, or that is on moments. Okay? So, ito yung ating displacement numbering or freedom numbering. Remember na kapag may rotation or may angle na nangyari, that is also displacement. So sa node 1, it is free to rotate. Kaya meron tayong displacement dyan. At hindi siya magdi-displace ng horizontal or vertical. Kaya this is D1. Okay? And that is rotation kaagad. Okay? Ayan. And then at node 2, meron tayong horizontal, and then meron tayong rotation. Ngayon, bakit tinanggal yung vertical displacement? Because the problem says ignore axial and shear deformations. So, ibig sabihin nito, wala kang displacement na vertical. Okay? Kaya ang V displacement magiging 0 lahat yan or wala. Okay? And then going back to the figure, kaya magiging ang displacement natin dito ngayon mag horizontal lang, or mag-sway yung building. So merong displacement dito na D2. And then at node 5 here, meron na naman siyang moment or merong rotation, that is D3. And then bakit dito sa nodes 2 and 5 parehas sila ng displacement D4? That is because yung amount ng displacement dito sa 2 tsaka sa 5 is parehas lang or considered as diaphragm yung level na ito. Okay? Ang ibig sabihin ng diaphragm, structure siya na ginagawa niyang parehas ang displacements at both ends. For example, yung floor slab, di ba? The floor slab is a stiff element. Kaya kung anong displacement dun sa kaliwa, ganun din ang magiging displacement dun sa kanan. So, parehas silang D4. And then, at node 4, dito, you have here D5. And then, at node 7, you have D6. And then, finally, dito sa level na yan, diaphragm na naman yan. So, that means parehas ang horizontal displacement sa node 4 tsaka sa node 7. at D7 ang na-number natin dyan. Okay? So, now let's review the numbering. At node 1 dito sa support, meron tayong D1 or that is 1. Ito. And then at node 2, you have two displacements, horizontal and rotation. Rotation is displacement 2. And then at node 5, that is displacement 3. And then, yung common displacements ni nodes 2 and 5, you have D4. Okay, so that is D4 under U. Kay D5, meron na naman, kay node 5, you have D4 under U. And then, ang common displacements naman dito sa level na yan, 4 and 7, you have D7 and D7. So, ayan. Node 4, you have D7 under U. And then, node 7, D7 under U. And then, finally, yung rotations sa node 4, D5 under rotation. And then, D6 under rotation kay node 7. Ayan. Okay, and next is yung loads naman. Dito sa ating spreadsheet, i-consider natin yung fixed end forces. Ibig sabihin yan yung mga forces na nandito sa nodes or sa ends ng member. Ngayon, ito ang ating loads nung problem. So, dito sa horizontal, as a vertical, meron tayong 40 kN acting towards the right. And then, meron tayong downward loads at members 2 and 6. Oh, by the way, before going there, ignore shear deformations. Yes, dahil ito ang kino-consider ni STAAD. Okay? So, kadalasan, yes lang yan. Dito tayo sa element numbering. So, element 1, that is 1 and 2. And then element 2, nodes 2 and 5. Then element 3, 4 and 5. Element 4, 3 and 4. Element 5, 6 and 7. And then element 6, 4 and 7. And then ang kanyang elasticity is 210 by 10 to the 6 kilonewton per meter squared. Ito. Okay. 210 by 10 to the 6 kilonewton per meter squared. Ayan. And then moment of inertia is ayan siya. For each member. Okay. So, ayan. 240 by 10 to the negative 6. Okay, or you just move the decimal places by 6. So, 0.00024. Yan yun. In meter units. Okay? Dito sa book, para madaling mag-compute, tsaka para madaling maisulat, ilagyan nyo yung exponent. And then, sa area naman, ito siya. This is in meter units again. By 10 to the negative 6 square meter. Okay? So, ayan siya. And then, ito naman. This is 2.46. And then, the beta factor is 0.061. Now, how do you solve for the beta factor? The beta factor is 12 EI lambda by ito all over GAL squared. So, yan ang equation ng 0.061. Okay? So, given yung E, given yung I, given yung G, area, and then length, tsaka yung lambda factor na yan. Okay? Pero, since we are going to ignore axial and shear deformations, yung beta factor na yan magiging 0. Kaya ito 0 ang nilagay ko na dito. Otherwise, kung i-consider mo yung shear otherwise, if you will not ignore shear deformations, then that's the time na magkakaroon ng value itong beta. Okay? So, ayan siya. So, in short, we will ignore shear deformations kahit i-disregard mo na itong ang lambda tsaka yung beta factor na yan. Ano? Ito, yung letter Y tsaka yung beta factor na yan. So, kahit 0 na lang yan, okay lang. Anyway, meron akong Excel dito kaya nilagay ko pa rin yan. Okay lang naman. Next is going back here sa loads. Paano naging 120 yan saka paano naging 180 ito?